Today we are starting a new chapter on Capecchi's Corner. We'll be looking at quadratic expressions and equations. Today we'll be looking at adding and subtracting polynomials. There's a lot of different vocabulary words we need to look at the beginning of this chapter. So when we're talking about polynomials, it's an expression made with constants, variables, so it could be numbers and letters, and exponents, which are combined using addition, subtraction, and multiplication. We have names for certain ones. We talk about a monomial. A monomial is when we have one term. For instance, if we have 4x or we have 2, they are each monomial. If we're looking at a binomial, the prefix bi means 2, so that's something that has two terms. So we have two terms which we're going to add or subtract. So we have 2x plus 3 and 7x squared minus 3. They are both binomials. The last one is a trinomial, which means 3. Tri means 3. So an example is 4x squared minus 2x plus 4. We're going to look at the word degree, which is the greatest exponent amongst the variable terms of the polynomials. And we have several different types. If we have a degree of 0, which would mean we would have the variable raised to the 0 power, which would be x to the 0 or y to the 0. So in the end, x to the 0 or any variable to the 0 is equal to 1. So you're actually not, in our example, we're not going to see x listed at all. We call that a constant. When we're looking at 1 degree, for instance, in our example, this is really x to the first. We don't write it, x to the first plus 2. That name is a linear. That's going to be line. When we have something to the second power, we call it a quadratic. And as you can see in our example, the highest power there is 2. And the last one we're going to look at is when we have a degree of 3. That means cubic. Something cubed is cubic. Our highest power there is to the third power. We often want our polynomial to be in standard form. And what that means is we want the terms written in descending order from the largest exponent to the smallest. Another thing we will ask a lot of times is, what is the leading coefficient? Remember, coefficient is the number before a variable. And when we use the word leading, that's the one obviously in the front. So a leading coefficient would be, when it's in standard form, the coefficient that is in front of the first term. So in our example, we have 4x to the third minus 2x squared minus 4x plus 10. This is in standard form because my degree goes from the highest, I have to the third power, to the second power, to the first, and then I have my constant. And also my leading coefficient, which is the term with the greatest degree in a polynomial. So right here, my greatest degree is 3, so my leading coefficient is going to be 4. Let's practice some of our vocabulary words. It says identify the type of polynomial, the degree, and the name by degree. So number 1, we have negative 3x to the second power, which is a monomial. It's just one term. The degree is 2. It's to the second power. That's the highest power there. And we call something that has a degree of a second power, we call that quadratic. That's the name of our polynomial, is a quadratic. In example number 2, we have 3 terms, 1, 2, 3. So we call that a trinomial. The highest power is again to the second power, so we can see that sometimes different ways. And again, that type of polynomial is called a quadratic. In our last example, we have 2 terms, so we call that a binomial. Our highest power there is 1. The degree is just 1. The c is not written to any power, so we assume that that's 1. And we call a polynomial with a degree of 1, we call that a linear expression right there, so that's linear. We are now being asked to write the polynomial in standard form and identify the leading coefficient. Now remember, standard form is we're going to go descending order from our largest exponent to our smallest. So in number 1, our highest exponent here is negative 6x to the 5th. So I'm going to write negative 6x to the 5th. And then I have 3x to the 4th. Now I don't have an x to the third power or the second power or the first power, which is fine. I just don't write anything. And then my constant is last negative 2. So that's that expression in standard form. Now my leading coefficient is right here. That is equal to negative 6. In number 2, my highest power is to the 9th power, so I have d to the 9th plus d to the 2nd minus 9d. and my leading coefficient here is 1. This is really a 1 in front. We don't write it, but we know that that's the coefficient that's there. In number 3, we have 3y to the 4th plus 2y to the 3rd plus 5y minus 8, and my leading coefficient is equal to 3 right here. Now you just have to be careful when you're writing a polynomial in standard form that each term is either a positive or a negative, and you have to make sure that those signs are going with that term when you're rewriting. So that's something you might want to double check before you do anything else with that polynomial. Now we're ready to add a polynomial. There's two methods you can use, a horizontal method or a vertical method. So I'm going to show you both. It really is a personal preference. I haven't really met any teachers that are specifically want one or the other. A lot of times they want you to practice both, so you can decide which way is best for you. So what we're going to do is we can combine like terms when adding polynomials. So we like to group things together. So if I look at number 1, I only have one thing to the 3rd power. That's 5x to the 3rd right here. So I'm just going to write 5x to the 3rd plus, now I'm going to group anything I have to the 2nd power. So in my first polynomial I have 2x to the 2nd. In my second polynomial that I'm adding I have 3x to the 2nd. So I'm going to put parentheses around that, group them together. Then I'm going to go x to the 1st power. So it gives me right here negative x. And in my second polynomial it gives me negative 4x. And then I'm left with my constants. So I have 7 in the first and 7 in the second. Now I can rewrite again in standard form. So I have 5x to the 3rd. When I add 2x squared plus 3x squared, I get 5x squared. And then when I add negative x minus 4x, it gives me negative 5x. And then when I add 7 plus 7, that gives me 14. So that right there is my final answer in standard form. Now we'll do the same problem using the vertical method. So what I'm going to do is I'm going to rewrite each polynomial again in standard form. So the first one is 5x to the 3rd plus 2x squared minus x plus 7. Now when I rewrite the second polynomial, I'm going to line it up in columns with like terms. It just makes it a lot easier when I go to add. So first I have 3x to the 2nd, which is going to go right underneath the 2x to the 2nd. Then I have my constant 7, so I'm going to put that over here again underneath my other constant. And then I have negative 4x to the 1st. I'm going to put that underneath that negative x, which is also to the 1st power. Notice I don't have any x to the 3rd, so I just leave that blank. And then that can happen in any term. In the middle of the polynomial, at the end, at the beginning, so you always just line up your like terms. Now I actually like the vertical method because I think it's easier for me visually because I'm taking the time to line them up in columns. So when I add these together, I get 5x to the 3rd plus 5x squared minus 5x plus 14, and that's my final answer. Notice it's the same answer I had when I added it using the horizontal method, because you're going to get the same result. You're still adding the polynomials, you're just doing a different method. Now this time we're going to subtract the polynomials. We have to be careful with subtraction because I'm actually need to distribute that negative sign. It's really like negative 1 through each of the terms of my polynomial that's listed second. So I have to be careful there. So sometimes I like to do that up front before I get started. So negative, remember that's like negative 1. So negative 1 times negative 2a to the 3rd gives me positive 2a to the 3rd. Negative 1 times 3a gives me negative 3a. And negative times negative 4 gives me positive 4. So now I have distributed that negative sign, so now it really just becomes an addition sign. So I'm going to do the same thing as I did in the last example when we added. I'm going to group my like terms together. So first I have negative 2a to the 3rd plus 2a to the 3rd. They are my two terms listed to the 3rd power. And then I have 5a to the 2nd in my first polynomial. Now notice in my second polynomial, I don't have anything to the 2nd power, so I'm just going to leave that. Now I'm going to the 1st power, so I have negative a minus 3a. And now looking at my constants, I have 8 plus 4. Now I can combine my like terms, so I have negative 2a to the 3rd plus 2a to the 3rd, which gives me 0, so I don't need to write anything. And then I have 5a to the 2nd, right there. And then my negative a minus 3a gives me minus 4a. And then my constants 8 plus 4 gives me 12. So there's my final answer right there. I'll do the same problem using the vertical method. So again, this time I'll rewrite my first polynomial. So I have negative 2a to the 3rd plus 5a to the 2nd minus a plus 8. Now remember, I've already distributed that negative sign, so I'm just going to rewrite once I've done that and line things up in columns. So that gives me 2a to the third. That's a positive if you want to write that, if that helps. Now minus 3a, remember that has to go under the other a to the first. And my constant there, 4. Combine my like terms. Negative 2a to the third plus 2a to the third gives me 0. And then I have 5a to the second. And then I have negative a minus 3a, which gives me negative 4a. And then I add my constants. 8 plus 4 gives me 12. So there's my final answer again, which matches the same polynomial when I added the terms using the horizontal method. Now we're going to find the perimeter of the rectangle. Now there's a couple different ways you can do this. We know that the perimeters, we're going to add all 4 sides. And we can take 2 times the length and add it to 2 times the width, but I think sometimes that gets a little confusing. I would just recommend to students just rewrite it. We know that this side is 2x squared minus x plus 6, so let's write that on the other side. It just gives us a better visual. And I'm going to do the same thing with the top. If the top is 5x squared plus 4x minus 1, then so is the bottom. Now, we can write this all out, but again, sometimes I think things get a little confused when you're rewriting things and there's a lot of terms. So I a lot of times just say, well, let's just add what we know. That's the same. So I have 5x to the second, 2x to the second, same thing up here, 5x to the second and 2x to the second. In the end, I know that gives me 14x to the second power. Then I'm looking at x to the first power. So I have 4x minus x plus 4x minus x. That gives me my 4x's give me 8x, minus 2x gives me plus 6x. And then I'm just looking at my constants. I have negative 1, positive 6, negative 1, positive 6. So 6 plus 6 gives me 12, and I minus 2, and I get 10. Now this is just units, whether it's feet or inches, not units square. We use that with area. So my final answer here is 14x squared plus 6x plus 10 units. Our next problem also involves perimeter, but this time we're looking at a triangle and it's a little different. It says the perimeter of the triangle below is represented by the expression 5x squared plus 3x minus 2. Write a polynomial that represents the measure of the third side. So in this problem, we're given the perimeter. We're asked to find the measurement of the third side. So let's just rewrite this. So I have 5x to the second plus 3x minus 2. Now again, there's a few ways you can do this. I think the easiest thing is just take one term at a time. So if my goal is to add the 3 sides up and get 5x to the second, let's see what I'm missing. I have x to the second plus 4x to the second, which gives me 5x to the second. So that means I'm not going to have a term that has x to the second on my third side. Let's do the same thing with x to the first. So I have 4x and negative 6x. So 4x plus negative 6x gives me negative 2x. What I'm trying to get to is I'm trying to get to 3x. So what I'm missing there is a 5x. So I'm going to write 5x here because 5x plus negative 2x is going to give me 3x. I'll do the same thing looking at my constant. I have a negative 3 and a positive 5. So negative 3 plus 5 gives me positive 2. I'm trying to get to negative 2. So how do I get to negative 2? I need to subtract 4. So my missing side is 5x minus 4. Now again, I can double check this by adding up my 3 sides. I have x squared plus 4x squared, so that again, I'm going to write this down here amongst all my arrows here. I have 5x to the second. If I add 4x and 5x, that gives me 9x. Minus 6x gives me 3x. And then if I have negative 3, negative 4 gives me negative 7. Plus 5 gives me negative 2, which if I look to what I was trying to get, that's exactly what I wanted. So my answer is 5x minus 4 is the measurement of my missing side there. In our last problem today, it says a polynomial expression is shown below. 5x to the third plus 6x to the second plus 3 minus 8x to the third minus mx to the second plus 2. And it says the expression is simplified to negative 3x to the third plus 4x to the second plus 1. What is the value of m? There's a couple things we need to look at here. First of all, this negative sign here, we're going to have to distribute that. And then we'll talk about what we're going to do with this m. So I'm going to rewrite the first, 5x to the third plus 6x to the second plus 3. Now I'm going to use a vertical method. I'm going to distribute that -1, and while I do that, I'm going to line up my terms. So that gives me -8x to the third plus mx to the second minus 2. Now the next thing I need to look, now that I've done that, I need to concentrate on that m. There's only an m in the x to the second column. So I don't really need to pay attention to the x to the third or my constants. I just need to look at that. So I'm trying to get to 4x to the second. So I have 6x to the second plus mx to the second is equal to 4x to the second. So 6 plus m is equal to 4. So obviously I'm decreasing in value, so I need to go down 2. So m is going to equal -2.